what is a sequence? So if you were to think of an example of a sequence, maybe something that comes to mind is like a list of numbers, a sequence, okay? So like 2, 4, 6, 8. So that would be an example of a sequence, okay? In this unit, we're specifically going to focus right now on arithmetic sequences. So our complete definition of a sequence is an ordered list of numbers that follow a pattern, okay? So here we have like the numbers 3, 5, 7, 9. Clearly, the pattern that they're following is that to get from one number to the next number, so to get from 3 to 5, they added 2. And then from 5 to 7, they added 2 again, and they keep on adding 2 to get the next number and then the next number, okay? So it's a list like this, separated by commas, and then there's a dot, dot, dot at the end, meaning that this list goes on forever, okay? And the order of this means that I can't put 7 at the front of this list, and then 9 after that, and then 3. I can't have the list be randomly ordered around. It has a very specific order. 3 has to be first, and then 5 second, and then 7 has to be the third term, and 9 has to be the fourth term, okay? So in a list, you can refer to the numbers in a list as a term, an element, or a member of that list, okay? So these words are interchangeable. So we're going to learn about some of the symbols or terminology that we're going to be using in this unit. So for example, A sub 1. So that little 1 that's to the lower right-hand corner, we call sub 1. This notates the first term in the sequence. So for example, in this sequence here, A sub 1 is going to equal, we would say that this is, it equals 3, okay? D is always going to represent, for an arithmetic sequence, the pattern. So essentially what the common difference is. So if I was to take A2, which if you can guess what that means, A2 means, well, A1 is the first term, A2 is the second term. So I take the second term and subtract the first term from it. And then if I repeat this process, so I take the third term, subtract the second term, I take the fourth term, subtract the third term, and so on and so forth. Every time I do this subtraction, I should be getting the same number. So this pattern, this plus 2, plus 2, plus 2 that we were looking at, that is what D equals. So we would say D is equal to positive 2, okay? And I can get that by using this common difference, which is really kind of unnecessary here for this sequence because we can clearly see what the pattern is. But for other sequences, or maybe you have decimals or fractions, it might be a little bit harder to tell what you're adding or subtracting by, okay? So this is a useful way to find out the common difference just in case you're a little bit unsure, okay? So like for example, like if we were going to test this out, like if I did A2, which is the second term, 5 minus A1, which is 3, I get 2, and that's my answer for D. That's what I was expecting. And I can repeat that process again if I do A3, which is the third term there, minus the second term, which is 5, I still get that common difference of 2. And this should happen every time I repeat this pattern. So like if I do 9 minus 7, I still get 2, okay? Okay, the next letter that you're going to see pop up is N. So N is going to represent the number's spot, the number's location in the sequence, okay? Like 7 is in the third spot in the sequence, okay? So A sub n is then going to represent the nth term in the list, okay? And we're expecting, whenever we have this, we're expecting to plug in a number for n, okay? So for example, here we plugged in 4 for n. So a sub 4 represents the fourth term in the list. Okay, so a sub n is just the nth term in the list where you're plugging some number in for n. Okay, whatever spot that is in the list. So maybe it's the 10th spot. If you plug in a 10 for n, maybe it's the 100th spot in the list, but this is talking about the location in the list. Okay. All right. Next, we'll look at the definition of an arithmetic sequence specifically, because that's what we're focusing on right now. So it's just a sequence where you have to add or subtract to get from one number to the next, like we were adding by 2 here. The number you add or subtract by must stay the same. So that's the big thing here. It has to stay the same from one term to the next. So that's why it's called the common difference, because it stays the same and all the numbers have this in common. So 2, that pattern is staying the same. It didn't change. So for example, we have another arithmetic sequence here where we're just adding 3 each time. To get from one number to the next, we're just adding 3. So this is definitely an arithmetic sequence. Where this list is not an arithmetic sequence, because we added 2 to get from 1 to 3, then we added 3, and then we added 4, and then we added 5. So there's definitely some kind of pattern here, but it's not an arithmetic pattern, okay? Because this number that you're adding by, it should be staying the same, okay? And so since this is increasing, it's not going to be arithmetic, okay? We just want this number to stay the same, or this number meaning our D. We want D to stay the same. Okay, so sometimes the pattern may be a little bit difficult to detect just by looking at the numbers, or there may not be a pattern at all, and it's not arithmetic. It's not an arithmetic sequence. So what we're going to do right now is we're going to determine if the sequences below are arithmetic, and if yes, find the common difference. So I want you to pause the video, try these 3 out, and then see what you come up with in just a minute, okay? So, is the first sequence arithmetic? So what I would do to figure that out, and it might be a little bit tricky, just because there's fractions in here and everything, but if I want to figure that out, I'm going to use this pattern that I was talking about up here to find the common difference. So I'm just going to take A2, so the second term in that sequence, which is 5 halves. And let's get some space here, so I can do 5 halves, and I'll subtract the first term, which is 2. So what is 5 halves minus 2? Okay, well, it looks like that's 1/2, or 0.5. Okay, so that's what we have so far for D. So now we just have to make sure that D is staying the same. So we just at least have to do this 2 more times is what I recommend to make sure that we are continuing to get the 0.5. Okay, so now let's do a sub 3 to the third term, which is 3, minus the second term, which is 5 halves. So what do I get then? So 3 minus 5 halves is 0.5. Okay, we're good. And we'll just try this one more time just to make sure. So 7 halves minus 3. What do I get for that? Also 0.5. Okay, so this pattern is definitely staying the same. So there is a common difference. There is a D of 0.5. And I would say because we're adding, because 0.5 is positive, we're adding 0.5 each time, that it is arithmetic. So yes, it's arithmetic. Okay, 2 more examples. So here, so testing out this pattern right now, I would take the second term, subtract the first term from it. So when I do 28 minus 34, I get -6. And then I'll do this process again. So 22 minus 28, what do I get there? Also a negative 6. And then let's try this one more time. So 16 minus 22. And again, I get negative 6. Okay, so this one, yes, it's arithmetic. Notice I have a negative number this time. So that means every time in this particular sequence, I'm subtracting 6 to get from one number to the next, okay? Instead of adding, now I'm subtracting. So my D is going to be a negative number, so D is negative 6. All right, and then the very last one, so let's try 7 minus 4, and I get 3. And then 12 minus 7, well, there I get 5. So right away, I can tell that this is not going to be arithmetic. This number should have been the same as this one, and I can confirm if I try this again, like if I do 19 minus 12, I get 7. So there's definitely some kind of pattern here, but it's not what I'm expecting. All of these numbers should be the same. So I'm going to say there's no common difference, so there's no D, and this is not arithmetic. Because arithmetic sequences should always have a common difference, okay, of the same number. All right, we're going to look at a couple more problems that you are going to encounter. So for example, let's say we had a sequence here, 34, 28, 22, 16, and we want to find the 89th term in this sequence. Because remember that this sequence keeps on going forever. What number is lying in the 89th spot? Well, you could just do brute force and keep on like subtracting, because we can see that the pattern for this one, right, is that they just ended up subtracting by 6 to get from one number to the next. So they subtracted 6, subtracted 6. You could just keep on doing that until you got to the 89th term. It would take you a very, very, very long time, but you could do it. Here is a shortcut instead of doing it that way. And especially that'll save you a lot of time if you're doing a problem like this on your SAT or ACT where it's a time test and you don't have all the time to get to that 89th term. Here's what you do. You're going to use this thing called an explicit formula. So this is actually a function, okay? We learn about functions. So it's a function that describes the pattern in the sequence. So you can use it to find any number at any location within the sequence, which is super handy for this problem. So here's our explicit formula for an arithmetic sequence, okay? So in a moment, we'll begin plugging numbers in to some of the letters that we see here. So we have a sub n equals a sub 1 plus d, and in parentheses n minus 1, okay? So let me write this down over here. So let's think about a couple of things that we can start plugging into this, okay? So for example, like a sub 1, what does this stand for? Well, a second ago, I just told you guys that a sub 1, that is the first term in the sequence, right? A sub 1 stands for the first term in the sequence. So the very first term is 34. So for this, I would plug in 34. All right, so now what is D? Well, we were practicing finding D just a second ago over here. Here I showed you that the pattern was that we were subtracting 6 every time, so negative 6 is going to be what we were plugging in for D. Okay, so I'll put in negative 6. And then the only other thing I have left to plug in is n. Okay, so if you recall, n is talking about the location, the number spot or location in the sequence. So we specifically want to find the 89th spot in the sequence? What is the 89th term in the sequence? So we're going to plug in 89 for n. Okay, and everywhere that I see an n, which is here and here, I'm plugging in an 89. Okay, so I'm going to keep this as an a, so I'll have a sub 89. And I'm not going to plug in anything for this a, because in a second, this a is going to tell me in the sequence what the 89th spot is. Okay, what is the number in the 89th spot? So the number in the 89th spot is, well, once we calculate all of this, so we do 89 minus 1, multiply that by -6, and then we'll add 34 to that to get negative 494. Okay, so line in the 89th spot waiting for us all the way down after we continue the sequence on and on and on and on and on is this number, negative 494. So that's the number in the 89th spot. Okay, so let's try out two more problems. We're going to create now another explicit formula. So let's say we know that a certain sequence has a common difference of -5. Okay, so let me start translating this right now into something that we can use for an explicit formula. So common difference of -5 means that d is -5. And then the first term is 14. So that means a sub 1 is 14. Find the explicit formula for the sequence. Okay. So all they gave me was d and a sub 1. Okay. If I'm making an explicit formula, okay, those are the only two things I'm going to plug in. Okay, so check this out. So if I have a sub n, I'm not plugging anything in for n right now, equals the first term, which is 14, plus -5. I'll just write that as -5 minus 5, multiplied by n minus 1. Okay, so here's our explicit formula. It's ready to go, and I can use it if I need to. Okay, so if I wanted to actually use this, I have to plug in some number for n. Okay, so it's ready to go, and if I wanted to use it, I'm using it to find a number at any location in the sequence. Okay, so if I wanted to find the number in the 99th spot, then I would plug in 99 for n and n here. Okay, right now I'm not going to use it. Okay, I just want to have it around just in case I need to use it. So I am going to prefer that for explicit formulas, and I think it's like this in Canvas, you need to simplify this a little bit further, okay? Specifically the right-hand side. So what we'll do now to simplify this is this -5 here. Really be careful with this, because I see most oftenly that when people mess up with simplifying this, they try to do 14 minus 5. And that's the first thing that they do. And it like kind of just draws your attention for some reason. You're like, I should do this first. Don't do that, because if you're doing the order of operations, the first thing you have to do is take this -5 and distribute it, okay, to both of these terms. So watch out, do not add or subtract these two numbers together. Make sure you distribute d first, okay? All right, so we get -5n plus +5, and then now I can combine my like terms to get -5n plus 19. And that would be our explicit formula. And if we wanted to use it, if we wanted to find a term in this particular sequence, we just plug in some number for n. So I kind of want to show you how this format is very similar to a function. We're just using different letters, and it looks just a little bit different. So a sub n, we could think of this looking like f of x, okay, where the n is similar to the x here. Like we're plugging in a number for n, and we could just have negative 5x plus 19. So we've seen something like this before. We know that this would be a function, just like this explicit formula is a function. So when we need to use this function, we could then plug something in for x and for x here, and find a spot on this line, okay? We could put an input in and then see what the output would be. Similarly here, we could put an input in for n and get an output, okay? So think about it as being similar to a function, okay? All right. One other problem we'll do here is we'll find the explicit formula for the arithmetic sequence, and then we're going to use it to find the next term in the sequence. So this one, because I just showed you how to find an explicit formula, that was it. Here's our explicit formula. I'm going to have you take a second, pause the video, and see if you can come up with your own explicit formula for this problem. Okay, so the first two things I have to find and that I used to make my explicit formula are D and A sub 1. Okay, so those are the two big things you have to make an explicit formula. So A sub 1, it's pretty easy, that's just 3/4. D, well, what is the pattern here? So remember, I'm using this trick here to find the common difference, so I'll just do the second term, 5/8 minus the first term, which is 3/4. And then what do I get? Well, 5/8, which is 0.625, minus 0.75, and I get negative 0.125. Okay. I can do this again just one more time to make sure it's arithmetic, but it probably is because I'm using it for this problem, right? So 1/2 minus 625, and yep, I get the same number again. So that's definitely my common difference there. And it's also just a nice thing to try it at least one more time, just to make sure that you did your math correct the first time. Maybe you did something a little bit off, and you're just double checking your answer again. Okay, so there's A sub 1, and then there's D. Let me write this in blue, actually. And then now, all we have left to do to get our explicit formula is we just have to plug them in, okay, into this right here. So I'll just write A sub n equals 3/4 plus, and then notice the D is negative, so I can just write this as negative 0.125, n minus 1. I'm actually just going to write this 3/4 as a decimal. Let's just make everything a decimal, so 0.75. Okay. And then now we just got to simplify this a little bit further, so I'll take that negative 0.25 and distribute it to both of those terms. Okay, so I get negative 0.125n plus 0.125. And then I'll just combine my like terms of these two numbers there and there. So negative 0.125n. And if I add those two numbers together, so 0.75 plus 0.125, I get positive 0.875. All right, and there is our explicit formula. Okay, maybe you kept it as fractions the whole time. That is totally fine as well. Okay, so you kept it as fractions and continued that problem. All right, so now let's use it to find the next term in the sequence. Okay. So if we're actually going to use our explicit formula, well, the next term in the sequence, that would be the 5th number. So I'm going to find what is happening in the 5th spot. So if I go ahead and plug in 5, for both of the ends what is the number in the fifth spot? Okay, so just kind of throw that into Desmos or calculator if you have it, times 5, and then we add that to 0.875, and I am getting 0.25 or 1/4 or 1/4, okay? So the very next number in the sequence should be 1/4. Okay. I have one last problem I do want to go over, which is kind of just more of a word problem using the concepts that we've gone over so far. So for example, in an arena, we have some seats. So the seats in each row form an arithmetic sequence. If row 1 has 14 seats and row 2 has 16 seats, how many seats are in row 50? So again, by brute force, we could kind of just keep on going through this pattern until we got to row 50. But what might be a little bit easier is if we found an explicit formula and then plugged in 50 to see what's happening in the 50th row. So using the clues from this problem, it says that row 1, so a sub 1, is 14. And then row 2, which I can make that a sub 2, that's 16. So far, in order to make my explicit formula, remember the two things that I need to have D, and I need to know what a sub 1 are, okay? So the two big things. I already have a sub 1, so now I just have to find the pattern, which is D. So it looks like the pattern is that they're just adding 2 each time. So from 14 to 16, they just added 2. And that's all that I can assume just because they only give me 2 rows. So from just those 2 rows, that's the pattern that I'm assuming that's going on, because it is an arithmetic sequence. Okay, so now that I have that, if I was going to make my explicit formula, 14 plus 2 multiplied by n minus 1. So I'm plugging in a sub 1, and I just plugged in d there. Simplify it a little bit further. And then there's our explicit formula. So now we can finally use this to find out how many seats there are in row 50. So if I plug in 50 for n, how many seats are in the 50th row? So we get 100 plus 12, so I get 112 seats.